Hi, hello, welcome back to our beloved channel, your favorite channel, Chemistry with RK. So today I have come up with a new concept. There have been continuous requests from the student side. There is, sir, we have problem with the aromaticity. So could you please explain that aromaticity, since the concept is so important for either NEET point of view or IIT point of view. So I have thought that, let us do a video on aromaticity. So from past so many years, they have been giving continuous questions on this aromatic character of different compounds. So I have selected so many questions from this aromatic nature, aromaticity. So let us start without any delay. Just I request you, if you are new to the channel, please do subscribe. Yes, I have been getting continuous support from all of you, but please, I request you to spread my channel. Those who are in need, they will get benefited. Let's continue. Let's start our discussion for today, that is aromaticity. In this video, I am going to include all the questions which are asked in previous NEET and JEE and advanced. And then I am going to take a complete one-shot course on this aromaticity. So you can able to solve maximum number of questions related to aromatic, non-aromatic, anti-aromatic, even the dipole moments, even the acidic natures, pKas, Kas and everything. Okay, so the questions related to aromaticity are very important, and then I am reminding again, please do watch this, try to separate the questions, try to write down all the information I am giving in this video and try to make your own notes, so that will become easier when you are in the end of your preparation. So let's start our video without any late. Just if you observe, yes, firstly aromatic hydrocarbons, which includes benzene actually. Okay, benzene related compounds, but I have taken a few aromatic compounds ka examples. Okay, and then firstly let us see, the flow chart of organic compounds. Generally, they are aliphatic and aromatic. Yes. And now when it comes to aromatic compounds, we have two types, benzenoid and non-benzenoid. So what does it mean? Aromatic compounds could be benzene related compounds, which mean the compounds in which at least one benzene ring is present. So such type of compounds are called as benzenoid compounds actually. Okay, aromatic benzenoid compounds. And then the aromatic compounds could be non-benzenoid compounds also. We can have other than benzene, there are so many compounds like pyrrole. Yes, you have pyrrole. So this is actually a non-benzenoid compound, but still it is aromatic. Yes, we are going to see all such type of examples. So non-benzenoid compounds, yes, as I have given here, organic compounds which have sweet and pleasant smell are called as aromatic compounds. And then yeah, the word aroma means the sweet smell actually. Okay, so the pleasant smell. And the next, aromatic compounds having at least one benzene ring in them are classified as benzenoid compounds. Yes, if we have a normal 6-member ring with alternate double bonds, then we call it as benzene. And then if we have 2 benzene rings fused with each other, then it is called as naphthalene. And then 3 benzene rings, anthracene. And then actually if this ring is present in the other position, then it could be phenanthrene also. This is anthracene and phenanthrene. And then next, so these are all about benzenoid compounds. Yeah, aromatic compounds not having benzene ring in them, but still they are aromatic. Don't forget. Okay, we don't have a benzene ring, but still they are aromatic. So such type of aromatic compounds are non-benzenoid aromatic compounds. So you can see here, yes, this is not an benzene. This is not having a benzene ring, but still, what do you say? It is aromatic. So it is said to be non-benzenoid compounds. So let's move on to the next. So in order to define whether aromatic, anti-aromatic or non-aromatic, we need to define few rules. Just okay, if we can understand those rules, we can easily define what type of compound, the given compound is whether aromatic or non-aromatic or anti-aromatic. Okay, so let us just go with that. So to tell a compound is aromatic, we should look at some condition. Okay, so we need to look at some conditions. What are those conditions? The first and very important one is Huckel's rule. Okay, so we need to define, or we need to observe whether the given compound is following Huckel's rule or not. So what is Huckel's rule actually? So Huckel's rule is 4n plus 2 pi electrons. The compound need to have 4n plus 2 pi electrons. where the n, okay, so where n could be any whole number. So it could be any number. So what does it mean? So by taking the n value, suppose let's say if you take n equal to 0, then we will be getting 2 pi electrons, right? And then if you take n equal to 1, then we will get 6 pi electrons. Then if you take n equal to 2, then we get 10 pi electrons. So by taking any of the whole number in place of n, if we are going to get some pi electrons which are also present in our given compound, then which mean that the compound is following Huckel's rule. Chalo, parallelly I will try to take one example here, very well known example. So for just time being I am taking here benzene. अभी देखो benzene में we have 3 pi bonds, which mean that 6 pi electrons. We know that in each bond we will have 2 electrons. So since we are talking about pi bonds, so 3 pi bonds are there, 6 pi electrons are there, right? And now this 6 pi electrons is matching with the Huckel's rule, that is if we take n equal to 1, agar hum n equal to 1 liye, then we will be getting 6 pi electrons. So which means that benzene follows Huckel's rule. I hope you understood, right? And then the second rule we need to observe, that is in that compound, in that ring, whatever central atoms we have, okay, so in that particular ring, whatever central atoms we have, the central atom must undergo sp2 hybridization. Very important. So central atom must undergo sp2 hybridization. Agar हम इधर देखें तो, so observe here, so this carbon again, so obviously this have a hydrogen, don't forget, okay. So there are 3 sigma bonds here, 1, 2, and then एक double bond में एक sigma bond होगा, right? And now 3 sigma bonds, there are no lone pairs with the carbon there, so obviously this carbon is given sp2. Similarly this carbon also, the same thing. We know that all the 6 carbons undergoes sp2 hybridization. Yes, it is following the second rule also, that is all the central atoms in the compound need to undergo sp2 hybridization. Yes, hope it is clear. Yes, so the first rule is satisfied, and the atoms in the cyclic ring, the central atoms in the cyclic ring must undergo sp2 hybridization. And the next one is in most of the cases, if all the central atoms are sp2 hybridized, then we can expect the molecule to be planar. We have few few compounds which look like they are sp2 and all the atoms are present in planar, but they are not in exact. We will see that particular exceptional molecules, compounds I will be taking, don't worry. But before that, please you try to understand, most of the cases में sp2 hybrid, अगर compound में all the central atoms are undergoing sp2 hybridization, then we can able to say the molecule is satisfying or molecule is following the planarity condition. Yes, the molecule must be planar, right? And then the fourth one is conjugation. The molecule, the compound need to have conjugation. Yes, conjugation. The cyclic ring should have conjugation. So what do you mean by that? What exactly the conjugation mean? Generally, what do you mean by conjugation? That will be clearly discussed in the mesomeric effect actually, right? And then conjugation, the word conjugation is very important here. So generally we observe conjugation when we have alternate double bonds. Yes, I'm writing here, when we have alternate double bonds, that is single bond, double bond, single bond, double bond. In such cases we can see conjugation. And even in the double bond, single bond with a positive charge, a double bond, single bond with a negative charge, double bond, single bond with a lone pair, and even double bond, single bond with free radical. Mostly in these cases we can see, apart from these 5 cases we have so many, but majorly we are going to deal with this. Till now, whatever questions we have got in the IIT and NEET point of view, yes, more than enough. These conditions, these concepts are more than enough, don't worry, okay? Right, and now keeping these 4 points in mind, we can able to say that, yes, the molecule, the compound which is going to satisfy these 4 rules, generally, yes, we are going to consider it as aromatic compounds. If suppose any of these 4 rules are violated, then the compound is said to be non-aromatic. Very simple. अगर इन चारों rules को follow किए तो that is aromatic. If the compound is violating any of these four rules, then it is said to be non-aromatic. And there is something called as anti-aromatic also. There is something called as anti-aromatic. And now, what is the difference between aromatic and anti-aromatic? Okay, so I'm writing here, just a minute. You just observe here what I'm writing. So we can say that aromatic compounds is inversely proportional to non-aromatic compounds. Okay, right. And now, yes. And now when it comes to anti-aromatic compounds, yes. And now in order to define this anti-aromatic, the first rule in aromatic was Hakul's rule, right? But now here the Hakul's rule will not be there. There will be 4n pi electrons rule. Okay, in anti-aromatic system, generally it follows, anti-aromatic system follows, 4n pi electrons, where our n value could be 1, 2, 3, 4 and so on, right? And now what does it mean? Okay, what does it mean? So instead of following 4n plus 2 pi electrons rule, if it follows 4n rule, then it could be, because all the rules are not yet discussed, right? So it could be an anti-aromatic system. And then next, the second rule, yeah, same, sp2 hybridized. Third one, yes, it could be, it need to have the planarity. And then the fourth rule is also same. Yeah, fourth rule is also same, that is the conjugation. The molecule need to have a conjugation, right? Yes. If a compound follows 4n plus 2 pi electron rule, sp2 hybridization, and then planarity and then conjugation, yes, the molecule is said to be aromatic. And apart from any of these four rules are violated, then non-aromatic. And if among those aromatic rules, the first rule is replaced by 4n pi electron rule, then it is said to be anti-aromatic system, right? So very easy, I hope. So let's start discussing our examples I have taken here, right? If you observe organic compounds which follows 4n pi electrons, yes. And then next, the central atoms in the cyclic ring should have sp2 hybridization, cyclic ring should have conjugation, and then the compound need to have planarity. Okay, so let's see the first example. One example I am taking here, that is, yes, our favorite and well-known example. I am taking benzene. Okay, so in benzene, if you see this carbon, all the 6 carbons are going to undergo sp2 first of all, right? And now before that, please you check from your side whether the benzene follows Hakul's rule or not. Yes, it follows Hakul's rule, because we have 3 pi bonds. We have 3 pi bonds, which means that 6 pi electrons are there. 6 pi electrons bole to, yes, 4n plus 2 pi electrons mein n is equals to 1 liye to ye humko 6 electrons dega. And now those 6 electrons are present in our benzene ring also. In such case, we can say that benzene ring follows Hakul's rule, yes. And then next, if you see, all the carbons are undergoing sp2 hybridization, and then we have a planarity, okay. So since actually this is the trigonal planar geometry, we can expect if a central atom has 3 bond pairs with 0 lone pairs, yes, we are going to have trigonal planar geometry, yes. So such that if all the central atoms are present in sp2 hybridized, and then obviously we can expect a trigonal planar geometry also. So planarity is also followed, and then the conjugation, if you see the conjugation, yes, so that is double, single, double, single, double, single, double. So we are going to have this double, single, double kind of what do you say that, a conjugation, okay, right? So hence we can clearly say that benzene is aromatic, okay, benzene is aromatic, yes. And now by taking the help of these rules, we can able to define any compound, whether it is aromatic or anti-aromatic or non-aromatic, okay, yes. Yeah, next let's take the example of naphthalene. So if you take the structure of naphthalene, you can see two benzene rings fused to each other with alternate pi bonds. And let us now try to check whether the compound is aromatic or non-aromatic or anti-aromatic. So we know that, the first rule to, in order to say a compound is aromatic, we need to check the, the below rules actually. So, if you observe, the 4n plus 2 pi electrons Huckel's rule need to be followed. So if you see, there are 5 pi bonds, so totally of 10 pi electrons. So 10 pi electrons, if you place in place of n, that is in place of 4n plus 2, if you place n is equals to 2, then we will get 10 pi electrons. So which means that naphthalene follows Huckel's rule. And at the same time, the second rule that we know, that is all the central atoms in that compound need to undergo sp2 hybridization. Yes, in naphthalene you can see all the carbons are with double bonds, so which means that the carbons will undergo sp2 hybridization. Yes, if all of them are in sp2 hybridization, they are said to be planar. And then you are going to see the conjugation also, that is double, single and then double. Yes, so obviously since all the 4 rules are satisfied, so this particular compound is also aromatic. Yes, and then next, let us move to the next example, that is anthracene. Anthracene is also 3 benzene rings fused to each other with the alternate pi bonds. Okay, you can see the alternate pi bonds here. Yes, you can see alternate pi bonds, which means the total number of pi bonds are 7, so pi electrons are 14. So 14 pi electrons, so you can able to understand, if we take in place of n, if we take 3, then 4 3 is 12 plus 2, so totally of 14 pi electrons we get, which means that anthracene follows Huckel's rule. And then next is all the central atoms. If you see all the central atoms, yes, they are going to show sp2 hybridization. So you can see alternate pi bonds also, so which means that all the central atoms will undergo sp2 hybridization. So all of them, if all of them are in sp2 hybridization, then obviously the planarity rule is also obviously followed. And then next, the last conjugation rule is also followed by this anthracene. So this is also said to be aromatic. Yes, the difference only between the anthracene and phenanthrene is the placement of this ring. So you can take the example of phenanthrene, which I didn't give in that particular video, slides, but you can take the example of that phenanthrene. This is anthracene, and now I am going to give that is phenanthrene actually. Yes, phenanthrene is this. So you can take the example of this, and then that is also said to be aromatic actually. Okay, so anthracene and phenanthrene, even chrysene is also actually it is almost like the same like anthracene and phenanthrene, but we will have 4 benzene rings fused with each other. Okay, so 4 benzene rings fused with each other like this. So this is actually called as chrysene. Yes, chrysene. So this is also said to be aromatic. So if you just observe the placement of the double bonds. Okay, so I'm going to give you the double bond placement actually. So you can take the help of this and you can easily predict the yes, this is actually the structure of chrysene. So chrysene is also actually, we have totally of 9 pi bonds, so overall 18 pi electrons. So 18 pi electrons, so obviously in 4n plus 2, so if you take 4n plus 2 में हमको n के place में 4 substitute करना है, 4 4 is 16 plus 2 18, so it follows Huckel's rule. All of them are sp2 hybridized. Obviously it is said to be planar, and then even the conjugation is also satisfied. So in this particular case we are going to observe all these rules are followed. And then next let us take the example of cyclopropene. Okay, so cyclopropene को एक बार देखेंगे. Okay, so let us take the example of cyclopropene. So cyclopropene is actually, yes, we know cyclopropene is this. And now how many pi bonds you can see here? So that is, we have only 1 pi bond, which means that 2 pi electrons. Yes sir, we can able to substitute in place of n, if you substitute 0, then we are going to get 2 pi electrons. So which means that cyclopropene follows Huckel's rule. Okay, and the next rule, if you observe carefully, this is actually the sp2 hybridized carbon. This is also sp2 hybridized carbon, but whereas this particular carbon is not sp2, that is sp3. So which mean that not all the central atoms are going to be what do you say that sp2. So which mean that one of the carbon, at least any of those aromatic rules are what do you say that violated, then we can able to say the compound is non-aromatic. So obviously we can go with cyclopropene is non-aromatic. Yes, it is non-aromatic. I hope you understood. So it is very simple to understand. Okay, and now next I'm moving with the cyclopropenyl cation. So cyclopropenyl cation को एक बार ले लेंगे, cyclopropenyl cation. And now what is actually cyclopropenyl cation is? Yes, this is actually cyclopropene, and now this is cyclopropenyl cation. And now just let us check. Yes, as usual, like the previous example, we have one pi bond, so 2 pi electrons. Yes, so it follows the Huckel's rule. Simply we can say 4n plus 2 pi electrons. So n ke place mein 0 le lo, then we will get 2 pi electrons very easily, right? And now which means that Huckel's rule is followed by the cyclopropenyl cation. And then next second rule को जाएंगे, एक बार second rule को check करेंगे. So this is going to be sp2 hybridized. This carbon is sp2, and then this carbon is also sp2 undoubtedly. And now if you just observe this carbocationic carbon, yes, this carbon is having a positive charge, which is nothing but carbocationic carbon. Let us just understand about the carbocation. So what do you mean by carbocation? So first of all, the carbons, actually it has 4 valence electrons before forming bonds with any of the atoms. And now after forming these 4 bonds with the opponent elements, the carbon is going to get octet. And now what do you mean by a positive charge, or when do we expect a positive charge on any element? When it loses an electron or loses more than one electron. So yes, we will expect a positive charge on atom when it loses an electron. And now what is the meaning of carbocation? Carbocation is the particular carbon has lost one electron and got a positive charge, which means that a carbon with positive charge is called as carbocation. And now if you observe carefully, this carbon, after losing its one electron, and now you can see actually, yes, after forming bonds, the carbon is going to get totally of octet configuration मिल जाएगा. अभी उस कार्बन ने एक इलेक्ट्रॉन को लूज हो गया, and now this carbon after losing electron, and now this is not going to have 8 valence electrons. Yes, please observe and tell me. Yes, you be ready with your answers. How many electrons this carbocation is going to have? Yes, don't say 7. Please don't say 7, because अगर 7 बोले तो this particular electron being lost, but this electron is not belong to the carbon. Now इस carbon का खुद का electron will be lost by that carbon, and now what it is going to have is a positive charge. Don't get misunderstand here. The carbon is going to have 6 valence electrons if you observe. Okay, so carbon का electron opponent element ने लेके बाहर चले जाएगा, then obviously carbon is going to have 6 valence electrons. So what does it mean? Yes sir, अगर इधर देखें तो कार्बन के पास 3 बॉन्ड पेयर है, 3 bond pairs and then 0 lone pairs, totally of 3 electron pairs. So when an atom has 3 electron pairs, which means that 3 hybrid orbitals it can able to form, which is nothing but sp2 hybridized. So मेरा बोलना ये है कि yes, whenever you see a carbon with a positive charge, you have to consider it as a sp2 hybridized carbon. So which mean that, coming back to our example, ये दो carbon तो directly double bonded carbon से तो obviously they are sp2 hybridized, and now because of the positive charge, yes, now I gave the perfect explanation here. Even the carbocation carbon also is going to undergo sp2 hybridization, which mean all of them are going to undergo sp2 hybridization, hence it is said to be planar. And then the last rule, that is conjugation. Yes, here we don't have a conjugation of double single like that, but we have a double single and a positive charge. So this particular example follows all the rules of aromaticity. So we are going to call this particular compound, that is cyclopropynyl cation, is aromatic in nature. Hope you understood. अगर कुछ problem है तो comment section में comment करो. Yes, I'll just try to give you some other best way of explanation. Okay. Yes. And then next we have discussed about cyclopropene, cyclopropynyl cation, and let us move to cyclopropynyl anion. एक बार इसका भी एग्जाम्पल देखेंगे. यस, साइक्लोप्रोपिनाइल एनायन के बारे में देखेंगे. यस, एंड नाउ यस, दिस इज ऑल्सो वन ऑफ द वेरी इंपॉर्टेंट एग्जाम्पल्स. अगर ये समझ में आए ना, अभी आने वाले बहुत सारे एग्जाम्पल्स यू कैन अंडरस्टैंड वेरी इजीली. प्लीज ट्राई टू अंडरस्टैंड हियर. यस, व्हाट इज द फर्स्ट रूल? यस, इट हैज one pi bond. Yes, so what do you expect? Yes, one pi bond, 2 pi electrons. Obviously it follows the 4n+2 Huckel's rule. But here one thing we need to understand, that is इधर जो भी negative charge है, that is going to be considered as 2 pi electrons. Sir, why and how and where? Okay, so in what type of cases we need to consider that negative charge as 2 pi actually, why do we need to consider that negative charge as 2 pi electrons? So please let us understand here. In the previous example we tried to understand about the carbocation, right? Similarly, let me take the example of carbon ion का भी example एक ले लेते. Yes sir, carbon has actually 4 valence electrons, its own 4 valence electrons before forming 4 bonds. And now after forming 4 bonds, yes, covalent bonds है तो credit आपका friend का credit आप भी ले सकते हैं. Before forming bonds, carbon used to have 4 valence electrons only. After forming bonds, yes, since they are now in bonding, since they have a friendship now, since they are in a good relation, so we have to consider the carbon can take the credit of the opponent element's electrons, and then opponent element also can take कार्बन का इलेक्ट्रॉन्स को भी वो खुद का स्टेबिलिटी में कंसिडर कर सकता है. ओके, एंड नाउ लेट मी जस्ट ऑब्जर्व हियर. सो लेट मी जस्ट टेक हियर दिस इज द अपोनेंट एलिमेंट्स का इलेक्ट्रॉन्स. ओके, एंड नाउ व्हाट इज द मीनिंग ऑफ नेगेटिव चार्ज? दिस इज क्वाइट अपोजिट टू द प्रीवियस केस. वो पॉजिटिव चार्ज कब आए थे? व्हेन इट लूजेस एन इलेक्ट्रॉन. एंड नाउ व्हाट अबाउट द नेगेटिव चार्ज? नेगेटिव चार्ज विल बी गेन्ड बाय एन एलिमेंट व्हेन इट गेन्ड एन इलेक्ट्रॉन. सो अभी कार्बन के ऊपर नेगेटिव चार्ज है तो उसके पास एक ज्यादा इलेक्ट्रॉन है. इट हैज वन मोर इलेक्ट्रॉन, इट हैज वन मोर इलेक्ट्रॉन, एक्स्ट्रा इलेक्ट्रॉन. वो खुद का इलेक्ट्रॉन को छोड़ के वो बाहर से कुछ एलिमेंट से एक इलेक्ट्रॉन ने गेन किया है. ओके, एंड नाउ प्लीज ट्राई टू अंडरस्टैंड हियर. एंड नाउ आफ्टर गेनिंग दैट इलेक्ट्रॉन, नाउ व्हाट इज द केस ऑफ कार्बन? अभी देखो कार्बन का केस ने कैसे बदल गया. ओके, सो यस, दिस इज गोइंग टू हैव 3 particular what do you say, that bond pairs are there. Okay, bond pairs are there of carbon. Yes, इधर देखो कार्बन का, just a minute. Okay, so yes, here what happens is कार्बन का it has its own own 4 electrons. उससे in addition to that, carbon has gained one more electron of its opponent. Yes, and now what does it mean? What you can understand clearly here is, yes sir, अभी क्या हो गया इस केस में? प्लीज ऑब्जर्व केयरफुली. सर, कार्बन के पास एक लोन पेयर आ गया, एंड नाउ दैट एक्स्ट्रा इलेक्ट्रॉन, कार्बन का खुद का एक इलेक्ट्रॉन है और बाहर से एक इलेक्ट्रॉन ने उस कार्बन ने एक्सेप्ट कर लिया. एंड नाउ दिस पर्टिकुलर कार्बन हैज वन पर्टिकुलर लोन पेयर. 3 बॉन्ड पेयर्स यू कैन सी हियर क्लियरली, एंड 1 लोन पेयर you can see. Totally of 4 electron pairs you can see, which mean that it is going to show, or it is going to undergo sp3 hybridization. Very interestingly, sir. Yeah, we can clearly say that these 2 carbons are undergoing sp2 hybridization since they are having double bond. And now, according to this particular concept, we need to give this particular carbon as sp3. Actually, here this carbon is having a negative charge which is called as carbene ion. Carbon with positive charge carbocation, carbon with negative charge carbene ion. Generally carbene ion का hybridization sp3 होना है, पर इस केस में थोड़ा अलग सा कॉन्सेप्ट अभी हमको दिखाई देगा. So if you observe carefully, so here we have a conjugation with respect to double, single and with a negative charge. So either whenever you have negatively charged carbon with the conjugation with respect to the carbon with the pi bond particularly, then there is a different concept arises. So what happens here is, when this particular negative charge is in conjugation with the double bond, especially it rearranges like this, and now this particular double bond will rearrange to give, there is one more resonating structure I am trying to draw here. So this particular negative charge will form a double bond here, and now this double bond need to go out. Yes, now what does it mean? Abhi idhar jo bhi negative charge the that formed a pi bond, which means that 2 pi electrons need to be considered. Just now, just few minutes back I told you a negative charge need to be considered as 2 pi electrons. I hope you understood why we need to consider 2 pi electrons actually. Abhi dekho aur ek point bhi idhar humko dekhna padega. So that is okay sir, we are convinced that okay, why a negative charge need to be considered 2 pi electrons here. Yes, I hope you understood. And now let us see why do we need to give sp2 hybridization for carbon ion also. So that is the carbon ion, when it is in conjugation with the double bond, it undergoes delocalization to give a pi bond like this. So hence a pi bond will be formed due to the negative charge. So we need to consider the negative charge as 2 pi electrons. I hope you understood. Right, and now if you observe, what about the hybridization? Hybridization B, either generally is carbon ko because of the negative charge we have given sp3. Okay, yes, there is a normal tendency to give it as a sp3, but now if you see in its corresponding resonating structure, is carbon ka hybridization kya ban gaya? That is sp2. I hope you understood. अभी देखो previous canonical structure और resonating structure में ये दो carbons को sp2 मिला है, and now generally we give this particular carbon as sp3, but now in its resonating structure this carbon, because of its delocalization, this carbon has given sp2 hybridization. Now let us see our example, that is cyclopropenyl anion. Okay, cyclopropenyl anion का example एक बार देखने के लिए कोशिश करेंगे. Now how many pi electrons you have now in cyclopropenyl anion? Previously you used to say that 2 pi electrons, and now we have a negative charge that need to be considered as a 2 pi electrons. As I told you in the just few minutes back, wherever you have a negative charge, when that is in conjugation only, please don't misunderstand. Okay, when the negative charge is in conjugation with the pi bond, only then we need to consider the negative charge as 2 pi electrons. In normal cases negative charge को 2 pi electrons consider नहीं करना है, and because of this particular conjugation with respect to the double bond or pi bond, we need to consider this negative charge as 2 pi electrons. Hope you understood. Okay, yes. And then next so if you see 4 pi electrons are there here, which mean that it is going to follow 4n pi electrons rule. Okay, so where n is equals to 1, okay, which mean that it must not belong to aromatic category, it need to be something else. Just let us see, just we can't say that just because it doesn't follow Huckel's rule, we can't say that it is a non-aromatic or anti-aromatic. Okay, we need to observe the rest of the 3 rules also. With respect to 4n pi electrons, agar baki 3 rules humko follow kiye to that is going to be anti-aromatic. Okay, and now 4n pi electrons hai, and then all of them are sp2. Yes, don't forget, normally carbon ion is sp3 hybridized only, but when it is in conjugation with the pi bond, it need to be considered as a sp2 hybridized carbon. Okay, and now all of them are sp2 hybridized here, all of them are sp2 hybridized, and then next all of them are sp2 hybridized, then we can able to consider it as planar, and then there is a conjugation also, that is double single negative charge. And now what it is going to be, this is going to be anti-aromatic. Yes, hope you understood. And now let me just give you a conclusion, that is, agar hum, yes, let me take cyclopropenyl cation, just cyclopropene, and then cyclopropenyl anion, in तीनों में, yes, we can just say that this is aromatic, this is aromatic, and this is non-aromatic, and then the last one is anti-aromatic, and this is anti-aromatic. Yes, and now if you see, if you just try to bother about their stabilities, we are going to have aromatic more stable than non-aromatic more stable than anti-aromatic. Okay, right, so that is how we need to define its stabilities also. Not only their aromatic and non-aromatic or anti-aromatic natures, with respect to their natures we can able to define the stabilities as well. And next let us move to our next example, that is cyclobutadiene. Cyclobutadiene क्या है? Yes, this is actually cyclobutadiene. And now how many pi electrons you can see? 2 pi bonds hai, then obviously 4 pi electrons, so 4 pi electrons we have, and then all of them are sp2 hybridized. Yes, you just please observe carefully, all of them are double bonded carbons, all of them are sp2 hybridized, and then obviously they are planar, and then they are having a conjugation as well. So obviously this is going to be anti-aromatic. Okay, yes, it is said to be cyclobutadiene is anti-aromatic. Hope you understood. And then next we have that is cyclopentadiene. I'm taking here cyclopentadienyl anion, cyclopentadiene and cyclopentadienyl cation. Yes, इन तीनों examples को एक बार compare करेंगे. And let us now look at the first one. Yes sir, here we have 2 pi bonds, yeah, which means that 4 pi electrons. As I told you earlier, there is a negative charge which need to be considered as a 2 pi electrons, totally of 6 pi electrons here. So totally of 6 pi electrons here, okay, and then if you see, all of them are sp2 hybridized. Yes, even the carbon ion also sp2 hybridized, I told you earlier. Okay, so yes, this negatively charged carbon is in conjugation with the double bond, so it is pi bond, so we can consider it as sp2. All of them are sp2, and now all of them are sp2, obviously it is going to follow the planarity rule also. You know the last rule, that is conjugation. Yes, it follows conjugation also. It follows actually 2 types of conjugations are there, double single double and double single negative charge as well. Okay, and now with respect to that, yes, since it is satisfying all the 4 rules of aromaticity, then it is said to be aromatic. Similarly, if you apply here the concept of aromaticity, here we are going to see 2 pi bonds, 4 pi electrons, no negative charge, no positive charge, so only 4 pi electrons. Okay, so 4 pi electrons, it could be anti-aromatic as well, बट बाकी 3 ऑप्शंस 3 पॉइंट्स भी सेटिस्फाई करना है अगर देखेंगे एक बार. एंड नाउ इफ यू सी दीज 4 कार्बन्स आर गोइंग टू हैव sp2 हाइब्रिडाइजेशन, but this particular carbon is not sp2, this is sp3. एक रूल भी वायलेट किया, then it is said to be non-aromatic. So cyclopentadiene is non-aromatic. And now cyclopentadienyl cation के बारे में बात करेंगे. Yes, here we have also 4 pi electrons, we have 4 pi electrons, and these 4 carbons anyway they are sp2 hybridized. In addition to that, this carbocation is also sp2, so which means that all of them are sp2, all of them are planar, and there is conjugation, double single double का भी है, double single positive charge का भी है. And now obviously it is going to follow all the 4 rules of anti-aromatic nature. So yes, it is going to be anti-aromatic. Yes, which means that sir, cyclopentadienyl anion is aromatic, cyclopentadiene is non-aromatic, cyclopentadienyl cation is anti-aromatic. And just if we bother about their stabilities, yes, aromatic, non-aromatic and anti-aromatic. Hope you understood. Within these 3 examples we can say their stabilities. You know, yes, we are going to have different types of examples. Let us continue. And then next, this is cycloheptatrienyl cation. Yes, cycloheptatrienyl cation को एक बार देखेंगे. It is generally called as tropylium cation. Yes, if you observe tropylium cation or cycloheptatrienyl cation also. So I have included this particular PDF in the description. That is, I'll be giving you, the Google Drive link. So please, you can download it from there. So this particular PDF you can directly download, and then you can just refer all these examples. So in this particular PDF, I have included almost from last 15 to 20 year JEE, NEET and different competitive exam examples, including advanced and mains. Irrespective of the exam, I have selected all the questions of aromaticity which have been given in different exams. Okay, yes. And now if you see the cycloheptatrienyl cation also, how many pi bonds you see? 3 pi bonds, 6 pi electrons. Yes, if you see, all of them are sp2 hybridized. Yes, irrespective of their natures, yes, we are going to have all of them are sp2 hybridized, planar, and then conjugation is also possible. Yes, this is going to be aromatic. Tropylium cation is aromatic. देखो एग्जाम में हमको डायरेक्टली वो स्ट्रक्चर दे सकते हैं, नहीं तो नाम भी दे सकता है. ओके, सो प्लीज डू रिफर बोथ ऑफ देम. try to have an idea. अगर cycloheptatrienol cation दिया, just you draw the cycloheptatrienol. Trine means 3 double bonds are there, cation. Yes, we are going to keep a cation in the top, or you can place anywhere. Okay, yes, I hope you understood. And then next, tropylium cation, that is a common name, so you need to memorize, you need to understand, you need to remember the structure so that you can able to solve them easily. And then similarly, let us move to this cyclobutynyl dication. Cyclobutynyl dication. Okay, so cyclobutynyl dication, if you observe cyclobutynyl dication, yes, isko ek bar comment karo. I'll be giving you some time, please you try to comment this particular example, whether it is aromatic or non-aromatic or anti-aromatic. Okay, I'm writing the name, you please comment your answers in the comment section with name and its nature. I'm writing here cyclobutynyl, okay, cyclobutynyl dication. Please you write down the name and then comment its particular nature. Okay, yes, anyway it will be there in the PDF. Don't try to dump that here, you try to do it on your own. अब तक मैंने जो कॉन्सेप्ट आपको एक्सप्लेन किया है, प्लीज यू ट्राई टू अप्लाई दैट कॉन्सेप्ट हियर एंड देन ट्राई टू आंसर. नो, प्लीज यू ट्राई टू कमेंट दिस वन ऑल्सो. यस, cyclobutynyl dianion, इसको भी एक बार कमेंट करने के लिए कोशिश करो. यस, इफ यू कैन डू दिस, यू कैन इजीली डू दिस. ओके, ये दो आने के लिए हमारा प्रीवियस प्लीज डोंट स्किप द वीडियो, यू वॉच इट कंटिन्यूअसली, डोंट स्किप इट, एंड देन सो दैट यू कैन एबल टू गेन मोर नॉलेज and then you will feel more confident to solve the questions. Okay, yes, this is actually cyclobutynyl dianion. दो negative charges है तो dianion. Clear? I hope you understood. Okay, so yes, I'm moving to the next one, that is, yes, and now this is a different type of example. This is a different type of example. Yes, देखो, normally what we are going to do, yes, if I ask you this particular compound whether it is aromatic or non-aromatic or anti-aromatic, generally yes, you apply the same rules, don't worry about, there is nothing we need to take from outside. अभी the 4 rules मैंने जो बताया, yes, you apply those 4 rules here to answer this. Okay, and now sir, here clearly you can see 2 pi bonds. 2 pi bonds means 4 pi electrons. 4 pi electrons, yes, it could be what we can understand, yes, it could be anti-aromatic or non-aromatic, obviously not aromatic, right? So yes, here what we need to do is, देखो, normally apply करो, normal points apply करो. अभी तक मैंने जो भी points explain किया है, you try to apply them here. So 4 pi electrons मिलेगा. 4 pi electrons, obviously no Huckel's rule, it is not following Huckel's rule with that. Okay, and now if you see these 4 particular double bonded carbons are going to undergo sp2 hybridized. And now if you observe this particular nitrogen के बारे में बात किए तो 3 bond pair है, एक lone pair भी है. And now what could be the possible hybridization for that particular nitrogen? Nitrogen is going to have sp3 hybridization, and now sp3 hybridization हो गया तो obviously it must belong to, generally you say that it is belonging to non-aromatic system, but this particular option is going to be wrong. ये ऑप्शन हमको ऑप्शन ए में देगा, बट प्लीज डोंट डू दैट मिस्टेक. अभी इधर कुछ अलग सा कॉन्सेप्ट है. एक्चुअली इट इज नॉट अ रॉकेट साइंस हियर, इट इज एक्चुअली नॉर्मल थिंग. वी नीड टू कंसिडर हियर अ स्मॉल पॉइंट टू बी कंसिडर्ड. इफ यू ऑब्जर्व, यस, इफ यू ऑब्जर्व, सर इधर कौन सी पॉइंट आएगा? ये जो लोन पेयर है, दिस लोन पेयर विल बी इन कॉन्जुगेशन. डोंट फॉरगेट सर, डबल सिंगल लोन पेयर, यस, इट इज इन कॉन्जुगेशन. देन व्हाट हैपेंस, दिस पर्टिकुलर लोन पेयर विल अंडरगो कॉन्जुगेशन हियर. ये पाई बॉन्ड में शिफ्ट होगा, एंड नाउ व्हाट इज इट्स corresponding resonating structure. Please observe here. सर ये डबल बॉन्ड तो ऐसे ही है, ये लोन पेयर इधर मूव हो गया तो डबल बॉन्ड इधर आ गया, एंड नाउ अ नेगेटिव चार्ज हैज कम ऑन दैट पर्टिकुलर कार्बन. एंड नाउ प्लीज ऑब्जर्व हाउ मेनी पाई इलेक्ट्रॉन्स आर देयर, हाउ मेनी पाई इलेक्ट्रॉन्स आर देयर. So there are 6 pi electrons now. So do we need to consider the lone pair on nitrogen every time? No, I will tell you. Easily you can able to predict. So when do that particular lone pair is going to undergo delocalization, or when do we need to consider the lone pair as 2 pi electrons? Actually, why we have considered here that lone pair as 2 pi electrons? Because it is forming a pi bond. Don't forget that point. ये जो लोन पेयर है इधर पाई बॉन्ड फॉर्मेशन में यूज हो गया. and now because of that we have taken that particular pi bond lone pair as a pi bond. Okay, and now totally of 6 pi electrons are there, which means that Akul's rule is followed. And then next second rule देखेंगे. Yes sir, yes, all the 4 carbons are sp2, as I told you earlier. Carbon ion is sp2 when it is in conjugation, don't forget please. Okay, and now nitrogen के बारे में देखें तो yes here simply we can say 3 sigma bonds, no lone pair. Even the nitrogen is also sp2 hybridization. Now compound में all the central atoms are undergoing the sp2 hybridization. Second point be satisfied, plenarity is also satisfied, last one is conjugation, which mean that इस compound का नाम है pyrrole. Yes, this pyrrole is finally we can conclude that pyrrole is aromatic. Superb. How come, you know, generally yes, अगर हम normal points को apply किया ना, non aromatic आ जाएगा, तेरा 4 mark चले जाएगा. Okay, please don't do that mistake. Either we need to consider this lone pair as 2 pi electrons. Sir, negative charge को भी 2 pi electrons consider करने के लिए बोले और lone pair को भी 2 pi electrons consider करने के लिए बोल रहे हैं. See, I didn't tell you to consider those negative charged and then lone pair as 2 pi electrons blindly. Please don't misunderstand. मैंने clearly उसका explanation भी दिया है. If you are watching the video directly from this particular watch time, please go back to the, please just rewind the video to understand why we need to consider negative charge as 2 pi electrons, why we need to consider a lone pair as 2 pi electrons. Clearly I have explained. Okay, right, please let's continue. So finally we can say that pyrrole is aromatic. And now let me take a beautiful example which gives more confidence in this particular aromaticity. And now here I am going to take, yes, this is the particular example. Don't forget nitrogen का भी lone pair ऐसे ही है. Yes, we know that nitrogen when it is forming 3 bonds it will have a lone pair, in its valency shell. And now my question is, this particular compound is called as pyridine. Yeah, this is a very well known compound called as pyridine. And now my question is, whether this pyridine is aromatic or non-aromatic or anti-aromatic. Yes, I'm giving you 1 minute of time. You try to solve this. Try to solve this. Yes, you apply normal rules only. Don't get confused or don't do anything. You apply normal rules. Yes, and then I'll give you anyway the final conclusion. Yes, you have to try this particular example from your side. Okay. Yes, let us not worry about the answer. Answer के बारे में worry नहीं होना. Please, I'll give you the explanation. Just you try to solve it by using our previous rules, previous concepts. Okay. Yeah, please मेरा channel को subscribe करो, like करो, share करो, comment करो. I'll be inviting all your suggestions. Please do, support my channel. Please follow. Okay, yes, within this very short span of time I have got very huge response from students and the viewer side, but still I request you to just spread my channel. Dekho, students can do anything. Okay, if you like my channel, if you feel that the information I am going to give you is really helpful, please do support. थोड़ा time दे दो, थोड़ा time spend करो मेरे channel पे. Please, you try to spread my channel. Chalo, let me just continue with this example here. Yes, normally if you apply 3 pi bonds are there, sir. 3 pi bonds are there. So 6 pi electrons. अभी पिछले example में आपने बताया, this lone pair, generally lone pair need to be considered as 2 pi electrons. But here this lone pair is not considered as 2 pi electrons. Why, sir? Why it is like that? अभी आपने बताया that lone pair need to be considered as 2 pi electrons. अभी आपने बता रहे इसको consider नहीं करना है. Yes, I told you there in the previous example, why this lone pair is undergoing the delocalization. Why this lone pair is considered as 2 pi electrons? Because if this lone pair undergoes delocalization, then that particular compound is going to get aromatic nature. But here in this example, इस lone pair अगर delocalization में अगर 2 pi electrons के जैसे consider करने से उसका aromatic nature lose हो जाएगा. Yes, I hope you understood. अगर इस lone pair को हम 2 pi electrons के जैसे consider किए तो then we will get 8 pi electrons totally. So no object in this universe would be interested to go from a stable state to unstable state. So yes, here this lone pair is not delocalized. Okay, so it is non-localized pi electrons. So it is non-localized lone pair. Okay, this lone pair is not going to undergo delocalization. This lone pair will remain as lone pair. So which mean that this pyridine has 6 pi electrons only. 6 pi electrons only. Yes. Hope you understood. And then all of them are sp2 including the nitrogen. Please don't forget, either a sigma, sigma lone pair. So 2 bond pairs, 1 lone pair, totally 3 electron pairs. So still it is going to get sp2 hybridization only. Yes, totally of all of them are sp2. All of them are planar. All of them have conjugation. Yes, so obviously pyridine is said to be aromatic. Hope you understood. Hope you understood. Okay, hope you understood. Chalo. And now let's move on to the next example. Yes, here I gave you furan. Okay, एक बार furan का भी देखेंगे. Yes, let me give you an example. Furan. Okay, furan is this. Okay, yes, this is actually called as furan. Yes, and now you comment your answer. Now you comment your answer. Actually, oxane has 2 lone pairs. Don't forget, oxane has 2 lone pairs. In addition to 2 pi bonds, oxane has 2 lone pairs. Sir, do we need to consider both the lone pairs as pi electrons, or do we need to consider only one lone pair as the pi electrons? Do we need to leave the lone pairs totally? That is the question obviously every student gets into their mind. Anything in this universe will not be interested to go from a stable state to unstable state. Yes, I am not interested to pull or push myself into an unstable zone. You yourself not interested to push or pull you into the unstable zone, right? Similarly, this molecules also, all the organic compounds. Yes, and now what happens here is, I hope you understood my point here. So here we have 2 pi bonds, so totally of 4 pi electrons, and we have 2 lone pairs, out of which only 1 lone pair need to be considered as 2 pi electrons. Only then it is going to give 6 pi electrons. This particular lone pair will remain as a non-delocalized lone pair. Okay, so here we need to consider only 1 lone pair to undergo delocalization, whereas the other lone pair will remain as a non-delocalized or undelocalized. Okay, so it will remain as lone pair itself, which means that totally we have 6 pi electrons. All of them are sp2. Yes, please observe here, 4 carbons are going to undergo sp2, and then even oxygen also. How come, sir? How come? So if you please see, it's a resonating structure. Yes, it is going to give us this particular structure. So when this particular lone pair is going here, this will go on to that carbon के oxygen के ऊपर एक lone pair ऐसे ही है. And now if you observe, anyway these 4 carbons undergoes sp2, and oxygen का भी 2 bond pairs है, एक lone pair है. Yes, obviously it is going to have sp2 hybridization, which means that all the 4 rules are satisfied. So furan, this is actually called as furan. Furan bhi aromatic hai. Furan bhi aromatic hai. Yes. Let me give you one more question here. So please you try to comment your answer about this sulfur. Actually this is sulfur. Okay, yes, the central atom is sulfur here. So I am going to give you this particular example. This is called as thiophene. Okay, thiophene. Yes, and now I want you to comment the nature of the compound. Okay, whether it is aromatic or non-aromatic or anti-aromatic. Okay. Yeah, let me go to the next example. Yes, here we have thiophene, but please don't take the help of the PDF. You try to do it on your own. And let me give you the next example, that is imidazole. Yeah, the structure, the compound is called as imidazole, which is a very famous example. This particular question have been asking in different exams continuously. Yes, and now this is actually the structure of imidazole. And now the nature of the compound, let us see. Actually we can see clearly 2 pi bonds, 4 pi electrons. अभी देखो, इधर एक नाइट्रोजन के ऊपर lone pair है, इधर भी एक नाइट्रोजन के ऊपर lone pair है, but only one particular nitrogen's lone pair is going to involve in the delocalization. Which particular nitrogen? I'm asking you. Suppose let's say if I label this nitrogens, this is first nitrogen and second nitrogen. Which nitrogen's lone pair is going to undergo delocalization? That's my question. Please observe carefully. Try to understand the concept and tell me. We are going to see that this particular lone pair will undergo delocalization, whereas this lone pair will remain with nitrogen itself. Okay. So no need to, or actually this nitrogen has a no need. Actually yes, everything You know, we are doing all our works, we are doing all our duties, we are doing all our the regular daily schedules, we are going to school, we are going to office, everything we are doing for our need. Okay, similarly here also nitrogen, it's this particular nitrogen have no need to undergo or no need to involve this lone pair in the delocalization. इस लोन पेयर के लिए नीड है, बिकॉज ओनली इफ दिस पर्टिकुलर नाइट्रोजन इन्वॉल्व द लोन पेयर इन द डीलोकलाइजेशन, this is going to get the aromaticity. Yes, hope you understood. Yes, so if we try to draw its resonating structure, okay, then we are going to take, so इस लोन पेयर ने हमको डीलोकलाइज होने के बाद, so okay, if you observe, डीलोकलाइज होने के बाद इधर हमको डबल बॉन्ड मिल जाएगा, नाइट्रोजन का खुद का इलेक्ट्रॉन ऐसे ही है, and now we are going to have a nitrogen with lone pair. Okay, yes, so we are going to have, so this particular bond will shift on to nitrogen, and now if you observe carefully, yes, all of them are sp2 and then 6 pi electrons, most importantly 6 pi electrons are there, all of them are sp2 and then planar, and then conjugation is also there. So finally this imidazole, this compound is very important, this compound is called as imidazole. Imidazole ring is actually called as a aromatic compound. Imidazole is aromatic. Yeah, next let's move on to the next example. Yes, I have given something different here, that is, yes, we have, this is the example I have selected, and now for this also we need to say that we need to comment about the nature of the compound, whether it is aromatic or non-aromatic or anti-aromatic. You can see clearly 2 pi bonds, 4 pi electrons, and then these particular 4 carbons are going to undergo sp2 hybridization, but whereas the boron is not satisfied with sp2 rules, sp2 hybridization rules. But so what we are going to conclude is ye sp2 nahi hai, and then yes, we are going to say this particular compound could be non-aromatic, right? But here what happens is, बोरॉन के पास जो भी हमको vacant orbital है, because of that vacant orbital we can see some some kind of sidewise overlapping, and then there is going to see partial double bond character, which we are going to see that this particular boron also need to be given sp2 hybridized. Please try to understand this. Okay, so wherever you see boron with 2 adjacent bonds, obviously boron के पास empty orbital तो होगा, and now that particular empty orbital with the sidewise overlapping is going to show some partial double bond character. So where we are going to consider, where we need to give the boron need to be given sp2 hybridization. So like that, 4 pi electrons are there, and then all of them are sp2, obviously planar, and then we are going to see conjugation as well. Then we must give this particular compound anti-aromatic. Yes, this is said to be anti-aromatic. हमारा options में non-aromatic भी देगा. Please don't select that particular option. Okay, please keeping that point in mind. There is one more example here related to the same thing, but here I have included 2 oxygens also. Oxygens भी include किया. And then yes, we know that oxygen के ऊपर दो lone pair होता है, and then yes, here we have a a pi bond also, and now we can clearly say that there is 1 pi bond, so 2 pi electrons, and don't forget इधर जो भी हमको lone pairs है, they are going to undergo in the delocalization में involve होगा, and then where we are going to see 6 pi electrons. Vacant orbital तो है, yes, same type of case in the previous example I have told you. So here also we are going to have the same kind of possibility. 6 pi electrons are there, all of them are sp2, all of them are planar, and then we have conjugation also. So this particular compound is aromatic. Clear? Next, let's move on to our next example, that is, it is a boron related compound is given. So yeah, this is what. And now, according to the previous rules, if we try to give, there are only 1 pi bond, so 2 pi electrons are there, so hence it follows the Huckel's rule. But when it comes to the next one, that is hybridization, so this particular carbons are both sp2 hybridized, and then even this boron also sp2 hybridized, since I have told you a boron with 3 bond pairs and then one vacant orbital is going to be considered as sp2, which I have explained just few minutes back. And but here there is no conjugation, and that to this particular carbon is not sp2, it is sp3. So obviously it follows only the one of the rules among the aromatics, so it is violating the conjugation and then also the hybridization. So hence it is said to be a non-aromatic. So it is said to be non-aromatic. Clear? Hope it is clear. And then next, just let me take the other example here. In place of this boron, if we just try to take what do you say, oxygen, suppose let me take oxygen here, and then don't forget we have oxygen के ऊपर 2 lone pairs तो होगा, right? And now this is the example. So this is the positive charge, okay, this is the positive charge, okay, this is the positive charge we have here. So yes, and now let us just apply the points here. So that is only again you can see only one pi bond here. So generally we think that 2 pi electrons, but please don't forget this lone pair is in conjugation with the pi bond, that is double bond. So hence it must be included or considered as the 2 pi electrons. So totally 4 pi electrons to hai, 4 pi electrons hai, and then these 2 carbons are anyway sp2 since they are double bonded, and then this is carbocation, I told you this is also sp2. And then now here just if you see oxygen will not be given sp2 but in its resonating structure or canonical structure. So just if you try to observe, so this particular lone pair will shift here, and then this particular double bond will shift onto the carbon to give a negative charge. So obviously hence we are going to get a double bond here. So in that particular case, so the canonical structure we are going to get in that particular case is going to be this one, okay. So just observe, so there is a negative charge, there is a positive charge, there is a double bond, and also with a lone pair. So hence we can say even the oxygen also is going to get sp2 hybridized. So all of them are sp2 hybridized. And then next if you see, so this is following all the 4 rules of anti-aromatic nature, anti-aromaticity, because 4 pi electrons are there, sp2 hybridization is there, and then obviously plenarity is followed, and then even the conjugation is also there. So since these 4 rules are followed, this particular conjugation is anti-aromatic. Clear? Hope it is clear. I am giving you as many as examples I can. And now let me just go on to this again another example, that is we have the similar type of example, but only the thing is I have given a negative charge here. So I have selected so many variety of different types of questions here. So please just try to get the benefit of this, and then please I request you to just share it to your friends also, so that they can also get this fruit of this particular video, okay. And then next, so if you see again, you can see only one pi bond, so 2 pi electrons, generally we see that 2 pi electrons. And now please don't forget, a negative charge is considered as 2 pi electrons only when it is in conjugation with the double bond. So totally we can say clearly that is 4 pi electrons. 4 pi electrons are there, and then these two are sp2 anyway, these two are sp2 hybridized double bonded carbons, and then even the carbene ion is also sp2 hybridized when it is in conjugation with the double bond. And so boron with 3 sigma bonds, that is 3 bond pairs with 1 vacant orbital, is also going to be sp2 hybridization. And then next it follows all of them are sp2 hybridized, and all of them even conjugation is also there, and then even plenarity is also there. So since these 4 rules are again satisfied by anti-aromatic rules, anti-aromaticity, so hence it is said to be anti-aromatic. Clear? So these are all the examples which are given in recent JEE, Advanced, and Mains and NEET. So NEET में इतना बड़ा और complicated questions तो नहीं पूछे जाएगा, but normal, the starting few examples whatever I have given, they have given, we have got so many times those questions in the different NEET papers. And then when it comes to all these are related to mains and then advanced level, okay. So just even this particular question is given in recent NEET actually, okay. Let us just discuss this particular question also. So let me take that. So we have here the cyclobutadiene, or this upon reaction with 2 moles of sodium, here we are going to get some product. And now the question is, so just let me just give you, this is, suppose let's say this is compound A. We are getting compound A, and now what is the nature of that compound A? That is the question asked in recent NEET actually. So what is that? Actually, what is the role of this sodium? So generally we know that sodiums are electropositive, so hence they loses electrons. एक sodium ने एक electron को lose करेगा, and then it is becoming Na plus, sodium ion बन जाएगा. और ऐसे ही और एक sodium भी है, and then we are going to get और एक Na plus. So overall in this particular process we are going to get 2 electrons. Okay, don't forget, that is what we need to get from this particular question. इधर 2 sodium देने का पॉइंट ये है कि एक सोडियम ने एक इलेक्ट्रॉन को लूज करेगा, 2 sodiums will lose 2 electrons. So here those 2 electrons will be distributed here in this particular manner. Please you try to understand here. So that is okay. So just I have removed that particular bond, double bond ने remove कर दिया, and now just you try to understand here. I am just taking those, actually we know very well in a bond we will have 2 electrons actually. Okay, and now those were the 2 electrons. Yeah, let me give this particular electrons with some other color so that you will understand easily. And now these 2 electrons I am just writing it here. Okay, so you just try to understand those 2 electrons, I am taking it here, and now what we are going to get. So now, sir, this pi bond have now it's completely broken, and now these 2 electrons will be combining with each other, and then they are going to give. So since these 2 electrons have been grabbed by this carbon, and now we are going to get 2 negative charges here. Hope you understood. So this is our compound A. So if you can understand carefully, each carbon is going to gain one electron from the sodiums, and then we are going to get these 2 negative charges on those 2 carbons. So now we need to define the aromaticity for this particular compound. And now if you observe carefully, how many pi electrons you can see? We have 6 pi electrons. So don't forget, the negative charges are also now considered as the 2 pi electrons since it is in conjugation. And then each of them are sp2 hybridized. All of them are sp2 hybridized. Okay, and then we have obviously planarity rule is being satisfied. And then we have also conjugation भी है, so obviously it is said to be aromatic. तो ब्यूटाडाइन को 2 moles of sodium से react करने से कुछ product A मिलेगा, whether it is aromatic or non-aromatic or anti-aromatic we need to define. Hope you understood. And then I have shown everything here. उसी cyclobutadiene को हमने, instead of taking 2 moles of sodium, if you take 1 mole of magnesium, yes, magnesium is also electropositive, and in fact it is going to lose 2 electrons. एक magnesium ने 2 electrons को lose करेगा. Instead of giving 2 moles of sodium, they can even give 1 mole of magnesium, because even 1 mole of magnesium is also going to do the same work like 2 moles of sodium. There 2 moles of sodium have given 2 electrons individually. Here 1 magnesium will itself give 2 electrons. So those 2 electrons again they are going to gain, and then we are going to get 2 negative charges. Obviously the answer is not going to change. Hence it is also going to be aromatic. Yeah, here we have another question, very important question actually. So strong base diya hai. So they have given a strong base. Here they have given cyclopentadiene. So just let us try to figure out the structure. Yes, we have 2 hydrogens here, and don't forget this, we have 2 hydrogens. Yeah, and now इसको strong base के साथ react किया है. So strong base, generally we know strong base will try to abstract a proton. So when this OH minus is going to go onto that particular what do you say, yeah, this OH ने इधर इसके ऊपर अटैक करेगा, and then this particular bond pair will shift onto this particular carbon, and then what we are going to get finally, so we are going to get, sir, double bonds तो ऐसे ही रहेगा. And now yes, we have a hydrogen, and इधर उस कार्बन के इलेक्ट्रॉन के साथ साथ इस हाइड्रोजन का भी इलेक्ट्रॉन उसके पास आ गया. So which mean that we have got a lone pair now. And now this particular lone pair, you please try to understand, since this lone pair is in conjugation with the double bond, firstly how many pi electrons? So totally of 6 pi electrons following the Akkul's rule. and then all of them are sp2. Yes, anyway these four, I hope you don't have any doubt in that. So these four carbons are going to give sp2 hybridization, but this particular double lone pair carbon also being given sp2 since it is in conjugation, and obviously here we are going to get a double bond in the conjugate resonating structure. And then next we have plenarity also. Plenarity rule is also followed, and then conjugation is also there. So obviously this is going to be, so here jo bhi product humko milega, that is going to be aromatic. Clear to everyone? And then next if you understand carefully, let me give you one more question. So that is cycloheptatriene. Okay, so let me just take cycloheptatriene. So again here also we have two hydrogens. इसको भी strong base के साथ react किया है. Okay, let us just try to react this with a strong base. In this case there is something different happens. See, again the intention behind the concept is same, but the role of the OH minus is different. Sir, in the previous example this OH is being attacked onto this hydrogen, but here this hydrogen will go away onto this OH minus. So why? Actually, suppose let's say ye idhar aa gaya in the like the previous example, and then we are going to get a lone pair here, so which need to be considered as 2 pi electrons. Overall we are going to get 8 pi electrons, but no system will itself push into the unstable zone, right? So obviously in order to avoid that, in order to restrict itself into being pushed into the unstable zone, so this particular hydrogen will itself go on to the OH minus, so which we are going to get here. So because of that you are going to get something like this. You please try to understand. ये hydrogen इस carbon का electron के साथ साथ H plus के जैसे OH minus के ऊपर गया, and now here we are going to get a positive charge. And now please, now you try to identify its nature, the nature of this compound. It's 100% aromatic. I hope you now understood why this H plus is being shifted onto OH minus in this example, and then why in the other example this particular OH minus is shifted here. Sir, anyway, every system will itself want to become stable, by undergoing some of the other process, right? So by understanding that point, so we can clearly say that there is 6 pi electrons. अगर ये OH इधर H plus के ऊपर attack किया होता तो then obviously we are going to get a lone pair here which need to be considered as a 2 pi electrons. Overall we are going to get 8 pi electrons, so then it is going into anti-aromatic zone or maybe non-aromatic zone. So obviously, so to restrict itself, so it will the H plus will go and attack onto OH, and then the system is going to be 6 pi electrons, and then all of them are going to be sp2. Please try to check. Since I'm going directly, I have explained so many examples, so I'm going a bit directly. So please you try to figure out, and then any doubts you please comment in our comment section. And then finally conjugation be possible hai. And then obviously because of that we can say that it is aromatic. Next, let's move on to our next example, that is azulene. The compound azulene is the 7-member ring fused with a 5-member ring. Yes, yeah, this is what azulene is, with alternate double bonds. You can see clearly. So totally of 10 pi electrons are there in that compound. You can see clearly that is 5 pi bonds, so it is obviously having 10 pi electrons. So 10 pi electrons are satisfied, so it is falling 4n plus 2, so which is the n के place में 2 लगाया तो, so then we are going to get 10 pi electrons, and then all of them are sp2 if you observe carefully. Yes, each of them is said to be sp2 hybridized. Each of the carbon is sp2 hybridized, and then plenarity is also followed. Plenarity is also followed, and then here we have a conjugation also. Hence the compound azulene is said to be aromatic. It is said to be aromatic, very important. So azulene, so in the exams From few years they have been giving the names instead of giving the structures. So if they give names, obviously we have to know the structure of that particular compound in order to define this. Okay, so it's very important. Generally in this type of scenario we see in the advanced, not in general NEET, in mains. So in mains and NEET they will give the structure, but in advanced they are trying in a different way, giving the names instead of the structures. Okay, the same azulene can also be written in this particular structure. Structural representation is also different. So both of them are same actually. So here a positive charge in a cycloheptadiene ring and then a negative charge in the cyclopentadiene ring. Okay, so both of them are same actually. Just it represents the alternate double bond position. That's it. Okay, and then next, if you move on to the next example, that is calicine. In calicine you can see a different type of example it is, which we didn't come across till now. And now, yes, sir, in calicine two rings are connected through a common double bond, which is generally called as exocyclic double bond. Okay, yes. And now in this type of examples, how to deal with or how to identify whether the compound is belong to which of the following aromatic systems. Okay, and now in order to define that, we need to do a small thing, that is, the double bond which is connected through common in the two rings, we need to just assume, actually we have 2 pi electrons in this, right? Yes, you just try to move these electrons to one of the carbons. Okay, and now agar ye electron us ring ke taraf move hua to, then what we are going to get? So the double bonds will not get disturbed here in this. Okay, double bonds will be remained as such. And now, but here, since this electron is moved onto this 5-membered ring carbon, we are going to get a negative charge on this, we are going to get a positive charge on this, right? Why to do that? Okay, just let me just first of all explain that, and then later you will understand. Okay, and now by doing this we are going to get a positive and negative side. We are not doing anything, we're just trying to move those pi bonded electrons to towards any one of the ring. Okay, so you may ask, sir, why only this electron moving towards this? You can have other case also. For that, let me just explain you further. Okay, and now first of all, after doing this, okay, let me just give you the other case also. Why to put you in a confusion? Yes, you just try to have this particular case also. Yeah, and now here let us take a positive, here let us take a negative. Yes, first of all let me define this. Okay, so those cases I have taken 2 cases here, and now just observe here what we are going to get is, sir, ये इलेक्ट्रॉन इस 5-membered ring के तरफ मूव होने से what is happening? Sir, just in this such case, what we need to do is we have to define the rules of aromaticity to individual rings separately. So what I mean to say is, yes, you please try to apply the rules of aromaticity individually for the cyclopentadienyl ring and then cyclopropenyl ring also. And now, sir, you can see there are 6 pi electrons. Yes, we can clearly say 6 pi electrons. All of them are sp2, and then obviously plenarity, and then even we have a conjugation. So this particular ring is said to be aromatic. Yes, very good. And now let's now try to do this, and then 2 pi electrons are there, and then all of them are sp2, yes, and then plenarity is also followed, and then is in conjugation is also there, and then even this ring is also aromatic. Yes, and now moving this electron in this particular direction is only correct. Why, sir? अगर इसको हम aromaticity rules apply किए तो here we are going to get 4 pi electrons, not 6 pi electrons. 4 pi electrons, all of them are sp2, all of them are planar, conjugation is also there. Then this ring is said to be anti-aromatic. Now, going back to our previous statement, that is, no system will try to push itself into an unstable zone. Obviously, it will be interested to stay in a stable zone. So, obviously, this is not the correct way of moving the electrons. I hope you understood. And even the compound is different. Do the same thing. Just you try to move the electrons in both the sides. See, just don't restrict yourself to one way of thinking. You do in both the ways, and then please, अगर एक कंपाउंड में अगर हमारा एरोमेटिक कंपाउंड मिल रहा है तो ऑब्वियसली द कंपाउंड इज सेड टू बी एरोमेटिक. Yes, let me just make it more simple for you. That is, among the given two rings, if any one of the ring is going to be aromatic, then the whole ring or the whole compound is said to be aromatic. Clear? Clear? Yes. Sir, what does it mean? It means that not necessary to have both the rings in aromatic system like this. अगर समझो एक रिंग एरोमेटिक है और एक रिंग नॉन एरोमेटिक और एंटी एरोमेटिक है, फिर भी just go with aromatic, the whole compound is said to be aromatic. So we can say the compound calicine is aromatic. Yes, hope you understood. Beautiful example. Okay, and then let me just go to next compound is indole. Okay, हमारा next compound है indole. Yes, the structure is very important. In the recent days, they have been giving the names, not the structures, as I have told you. So please be careful and be particular with the structures also. It's very important for advance. Okay, yes. And now, what about this? Yes, sir, you can see 8 pi electrons only, but not only 8 pi electrons, there is a lone pair which is in conjugation. So obviously this must be taken as a 2 pi electrons. So totally of 10 pi electrons, yet it is following obviously 4n plus 2 pi electrons Huckel's rule system, and then all of them are sp2. Yes, it is. There is no doubt, I hope. Okay, I hope it is clear to everyone. Please, since I have explained everything in detail in my initial or the starting my video, so I am moving directly. So please just stick to that, and then it is said to be planar. Okay, planarity ka rule bhi satisfy ho raha hai, and then what about the conjugation is also there. So yes, since all of them are followed, so the compound indole hai hamara aromatic. Okay, right? So simple, right? Very good. And the next, the last but not least, so this is our beautiful example called as quinoline. What is the difference between naphthalene and quinoline? Naphthalene, just naphthalene is what do you say? Two benzene rings fused together is called as naphthalene. अगर कोई भी एक benzene ring में एक carbon के place में, that if we have a nitrogen, then it is said to be quinoline. Yes, this is what exactly quinoline is. So now we can clearly say in quinoline the nitrogen's lone pair is no need to undergo delocalization. So obviously ये है हमारा quinoline. Yeah, the role of quinoline in organic chemistry is beautiful. That is, it is generally used in the Lindlar's reaction, that is controlled hydrogenation of alkynes. So by using this quinoline is generally used as a poisonating agent. Okay, so it is used as a poisonating agent in Lindlar's catalyst. Palladium BaSO4. With that we will take this quinoline. Yes, this is said to be Lindlar's reaction, where we are going to get cis alkene as a major product. Instead of doing this Lindlar's catalyst, if you take Birch reagent, we are going to get a trans alkene as a major product. Hope you understood. Right, let us continue. And then quinoline is going to be how many pi electrons? So 10 pi electrons are there, and then all of them are sp2 including the nitrogen, and then planarity rule is also followed, and then even conjugation is also followed. So quinoline is also aromatic without any doubt. Hope you understood it. Okay, as of now, if you have any doubts, please just take the I feel very happy to invite all your doubts and queries. And then next, yes, here I am very much eager to solve this type of questions actually. Yes, here what we are going to understand is, sir, this type of questions are very frequent nowadays. Okay, so ऐसा type का question को हम कैसे solve करना है? Just so simple बेटा. So just I have given few examples just now, that is cyclobutadiene को 2 moles of sodium से react किया, and then there is a compound, and then what is the nature of the compound? Yes, similar type of questions are there. Now instead of giving sodium or magnesium, we are going to have AgNO3. Okay, AgNO3 के साथ reaction कैसे होगा, और whatever the product we are going to get, what is the nature of that particular product? Okay, yeah. And now how to solve this? Nothing, it is so simple to see. There is iodine here, and then there is AgNO3 में Ag plus है, और हमारा compound में iodine है. And now what is the nature of this particular compound? If I ask you, yes, it is going to follow non-aromatic system rules. So this particular compound is non-aromatic. They may give this particular data directly in the question itself. बट द क्वेश्चन इज, अगर इस नॉन एरोमेटिक कंपाउंड को AgNO3 के साथ रिएक्ट करने से कुछ प्रोडक्ट तो इधर मिलेगा, व्हाट इज द नेचर ऑफ दैट प्रोडक्ट, दैट मस्ट बी द क्वेश्चन हियर. And now how to do this? Simple. This Ag plus AgNO3 में Ag plus जो है वो Agi के साथ precipitate बनेगा and then leaving a positive charge on the ring. So where it is going to be cycloheptatrinyl cation. cycloheptatrinyl cation मिलेगा हमको, cycloheptatrinyl cation. इस कंपाउंड का नेचर बताओ. ओके, सो दैट इज ऑब्वियसली 6 pi electrons are there, everything. Yes, if you please apply the rules of the aromaticity, yes, we are going to conclude it as aromatic. And now next, coming on to this second example, we are going to have, there is the same type of compound with iodine again. Yes, just remove Agi and then just take out a positive on that particular carbon. जिस carbon को I bonded है, just you take a positive charge on that carbon and then try to decide. Yes, if you see, this is the compound we are going to get in the second example, where one of the lone pair on the oxygen will undergo delocalization or considered as 2 pi electrons. Yes. Hope you understood. So again it is going to be aromatic. Similarly here देखो, just observe here, this is a beautiful example. अभी let me just take this particular example here. So that is, they have given, yes, 2 double bonds with iodine and then इसको AgNO3 के साथ रिएक्ट करने से Ag plus है, I minus है, ये बाहर जाएगा and then we are going to get, a positive charge. And now how to define this? So it's so simple. Okay, it's so simple. 4n pi electrons है, all of them are sp2 and then conjugation भी है, planarity भी है. Obviously it is going to follow anti-aromatic. Yes, we need to choose anti-aromatic among the given 4 options. That's it. Okay, and then yeah, this is what. And then next, if we see, let me just go on to the next examples. That is, yes, we have something like this. There is a normal compound. It is also so simple. Okay, yeah, yes, if you see, we have this and then इसको भी AgNO3 के साथ रिएक्ट किया, Ag plus है, I minus है, इसको इसके साथ निकाल दो and then we are going to get a positive charge. फिर भी we don't have any pi electrons in this. Obviously we are going to call this as a non-aromatic compound. Yes, any doubts in that? Nothing. Non-aromatic. अगर देखो नेक्स्ट कंपाउंड में क्या होगा, सर, इंस्टेड ऑफ गिविंग AgNO3 वी हैव हियर दैट इज HClO4 है. एंड नाउ जनरली व्हाट हैपेंस हियर, just let me take, that is, here we have something like this. This is also a very beautiful question. So we have 2 R groups here and then there is a double bond O, and then when we react this with HClO4, we have very clearly we can understand that is HClO4 is perchloric acid, which is an acid, strongest acid actually, which furnish H plus ion very easily. And now this particular hydrogen ने इस particular oxygen के साथ, oxygen के ऊपर 2 lone pairs तो है, and now it will grab that particular hydrogen and then we are going to get, what we are going to get is, इधर तो OH आएगा तो इधर positive आएगा. And now what happens here, this particular hydrogen will go out, H plus will go out with oxygen and then leaving a positive charge here. Okay, अभी इस ऑक्सीजन को इस हाइड्रोजन के साथ बॉन्ड फॉर्म करने के लिए एक इलेक्ट्रॉन तो होना है, वो इस कार्बन के इलेक्ट्रॉन ने इस ऑक्सीजन खींच के इस H plus को देगा and now there gets a positive charge. And now how to define? Just you define, it's so simple. 2 pi electrons are there and then all are sp2. रिंग में देखना है, इधर ऑक्सीजन को R ग्रुप को नहीं देखना है, रिंग में देखना है. ओके, एंड नाउ planarity is also there and then it is conjugation. Yes, in addition to this we are going to get ClO4 minus, which is perchlorate ion. We have an aromatic compound which is reacted with some other compound and then it is going to give some other product whose nature must be aromatic, because an aromatic compound will not be pushed into a non-aromatic or anti-aromatic. So even this particular product is also going to be aromatic. Clear? Right. Next, let's move on to our next example. That is, again I have selected here this question. That is cycloheptatrinyl with a double bond O reacted with same HCl4. You try to do it. You try to do it on your own and then try to figure out the nature of the compound in the product. Okay. Yes, it is going to be aromatic. Since it is aromatic, obviously it is also going to be aromatic. Yes, it's very easy. And now the same cycloheptatriene, okay, and then reacting with bromine के साथ react करने से इधर क्या होगा? And let us check with this reaction, that is cycloheptatriene is there, and then this cycloheptatriene is reacted with Br2. Yes, and now don't forget, yes, we have two hydrogens here. That is obviously एक hydrogen एक HBr के साथ जाएगा, and then because of this we are going to get one hydrogen will be there on that particular carbon itself. So finally we are going to get, that is the double bonds will be as it is, and then there will be a bromine in that particular carbon place where we are going to get a positive charge on this particular carbon. How? That is, one of the bromine has taken one H plus ion, okay, so that is obviously it gives us plus charge on that. Actually this compound is a non-aromatic system, and then by reacting with Br2 it is going to be an aromatic system. Similarly here we have CH3Li plus, which is actually alkyl lithium. So lithium is electropositive, lithium will lose one electron, and that particular electron will be what do you say, that the similar type of magnesium and sodium reaction, okay. Yes, if you see, yeah, this is actually cyclopentadiene, and then we have two hydrogens here, and then similar case like the previous one, CH3Li, where Li will have a positive charge, CH3 will have a negative charge, and now one of the hydrogen, so ये जो electron इधर से lithium से बाहर निकला है वो इस कार्बन ने accept करके, so that particular carbon will accept that electron, and then it is going to give us a cyclopentadienyl anion, so which is going to give us an aromatic compound. Aromatic compound मिलेगा. Yes, and then next finally, yeah, this is the compound asked in recent 2021 advanced paper. So that is actually bromine है. इस bromine से इधर they have given actually, okay. So just by taking this particular reaction, what we need to do? We need to identify the compound nature. So this is non-aromatic actually, you can see clearly, I hope. And then whereas by removing this bromine out as a Br minus, and then we are going to get a positive charge on that particular carbon, giving us an aromatic salt, okay. Yes, and then next let us move on to our next example, that is, and then yeah, here in the initial minutes of my video I have discussed that mostly 99.9% of the compounds or the central atoms which are with the sp2 hybridized is going to have plenarity, right? But except a few examples I mentioned in the starting. So that is these examples, these 2 or 3 examples where we need to be a bit cautious in terms. Actually we are lacking with that 3-dimensional imagination. So here this particular compound is normally the cyclooctatetraene है, जो compound है cyclooctatetraene. Yes, you can see this is actually called as cyclooctatetraene. Yes, where we are going to have alternate double bonds. Yes, if you apply normal rules of aromaticity, we are going to get anti-aromatic. This is actually we are going to get 8 pi electrons मिलेगा, and then all of them are sp2 मिलेगा, and then obviously sp2 है तो plenarity भी होता है, and then next is conjugation, yes, so hence it is said to be anti-aromatic, but which is not. This is what we need to understand here. ये जो compound है generally it exists as a tub shape के जैसे रहता है, and now yes, this is what the compound generally looks like, okay. Yeah, sorry, just a minute. Okay, yeah, this is how it looks like, okay. And now ये जो दो हाइड्रोजन्स इधर हमको दिख रहा है, so generally they are seems like they are present in one particular plane, but they are not. Yes, if you see normally if we go with the rules, then we are going to get anti-aromatic, but it seems that the compound is planar. ये जो हाइड्रोजन्स है दो वो प्लेन में हुआ है ऐसा हमको दिखेगा, but it is exactly not in a one plane. So there misses the plenarity rule. Okay, there misses the plenarity rule. So hence it is not anti-aromatic, it is non-aromatic. Okay, cyclooctatetraene का केस में yes, we are going to see this particular tub shape. We see the tub shape. Okay, yeah, we see this tub shape compound. Okay, yeah, very important. Tub shape, it will have tub shape compound, cyclooctatetraene. Because of that, the hydrogens are not going to be in the plane, so please keep that point in mind. And then next we have 10 cumulene. Actually, these are all cumulines. Okay, there are 8 cumulene, and then this is 10 cumulene. Why? What is a cumulene actually? Cumulene. So benzene is a 6 cumulene. What do you mean by 6 cumulene? 6 pi electrons containing alternate pi bonds containing a compound. So cumulines generally they are called as. And then this is a 10 cumulene. So if you see carefully, we are going to have this compound. Yes, here you can see. Yeah, observe this compound. You can clearly understand what I am going to talk about. So there are 2 double bonds here, double bond here, double. Yeah. And now if you see again, this is also seems like aromatic in fact. Okay, this compound seems like aromatic. Yes, because 10 pi electrons are there, all of them are sp2, plenarity and then conjugation. But what happens here is, ये जो hydrogen है, ये जो इधर का hydrogens है, they are out of the plane, they align out of the plane. Okay, so if you see, hence it is expected to be aromatic but not, it seems to be a planar structure but not exactly. The hydrogens are not in a plane, they are not in a plane, they are trans to each other, okay. And now keeping that point in mind, it is not following the rule of plenarity, so obviously we need to go with non-aromatic. Okay, yes, here this particular compound is also what type of cumulene it is? 1 2 3 4 5 6 7, so 14 cumulene it is. 14 cumulene, yes, it is said to be aromatic. Okay, so here what happens is, the hydrogens, the 4 hydrogens you can see here is again, so you may think that, sir, this is also a different type of example like the previous one where the hydrogens are going to have trans to each other. But here what happens is, the trans effect is going to cancel out with respect to each other actually. Okay, just a minute. The trans effect is going to cancel out with respect to each other. Because of that, what happens here is, this particular hydrogen, okay, let me just give some other color to this. Okay, yeah, these hydrogens are, since they are anti to each other, the anti-addition or the anti-effect will cancel with each other. So hence the compound is said to be aromatic itself. Okay, because the hydrogens, yes, they are anti to or trans to each other, but the trans effect will get cancelled because there are even number of hydrogens opposite to each other. Hence the compound is said to be aromatic itself. Okay, and then next, as I told you earlier in the starting itself, I have mentioned very clearly, that is aromatic, aromatic, non-aromatic, anti-aromatic में most stable is aromatic, and then followed by non-aromatic, and then followed by anti-aromatic. Okay, and now an aromatic compound is more stable than its corresponding open chain compound. Very important, it's so simple to understand. Okay, so what the point mean is, generally we know the benzene, structure of benzene is this. Okay, there are alternate double bonds, and now usi 6 compounds say, we can expect this particular compound. Yes, okay, there are 6, and now here also we can have 6 pi electrons, but the compound is not closed or not a ring structure, it is an open structure. So what the point exact mean is, an aromatic compound is more stable than the corresponding open chain compound with the same number of double bonds. Yeah, double bonds will need to be same in this particular case. Okay, and then next, an anti-aromatic compound is less stable than the corresponding open chain compound which has same number. This is quite opposite to that. Okay, so here what does it mean is, so let us just take cyclobutadiene. ये है anti-aromatic compound. Let us take just 1,3-butadiene. So this is anti-aromatic, and now this is having equal number of double bonds compared to this ring structure which is anti-aromatic. This is less stable than the corresponding open chain compound. So this is what the point mean. Okay, yes, and now next just let us go to this dipole moments. Yeah, this is also a beautiful type of model problems which we can expect which we can solve actually by using the aromatic system, aromatic rules. And now what happens here is, we have actually let me just take this. Yeah, we have a cyclopropanyl group, and then with a double bond O, and then we have cyclopentadienyl group with a double bond O. And then the question is, Compare the dipole moments. Compare the dipole moments. What we need to do? Actually, we know that oxygen is more electronegative. Oxygen is more electronegative. Okay, so we know that oxygen is more electronegative. Okay, so either just observe here, oxygen is more electronegative. Electronegative है तो वो क्या करेगा? So that will abstract the electron density towards itself. So because of this, what we are going to get here is the electron movement is towards the oxygen. Because of this, oxygen is going to get a partial negative charge and leaving a partial positive charge to the carbon. And then here also partial negative charge to the oxygen, partial positive charge to the carbon. Where, you know, partial positive means if oxygen pulls the electron completely towards itself, then we may have a choice to get a complete positive charge also. Okay, and now just keeping that particular point in mind, you just try to figure out the nature of this compound. Okay, ये 2 pi electrons है, and then all of them are sp2 hybridized, plenarity है, and then obviously it is said to be aromatic. So because of this electron movement, the ring is going to get an aromatic nature. And the same case here, if you observe, a positive charge है, and then 4 pi electrons है, and then sp2 है, and then plenarity भी है, and then conjugation भी है, and then because of that, it is going to get anti-aromatic system. It is going to have an anti-aromatic nature, which is comparably less stable than the aromatic ring. So obviously dipole moment. So here the carbon will be very much interested to leave its electron towards the oxygen to get the aromatic nature to its ring. Hope you understood. Very easy, right? Very interesting in fact. Okay, so you know, just it is a mutual understanding between the atoms. अभी इधर देखो, इधर same carbon है, ऑक्सीजन को इलेक्ट्रॉन देने के लिए ज़्यादा इंटरेस्टेड नहीं होगा. So I hope it is, you know, chemistry is, that's what interesting actually. If you understand the logic, if you understand the bonding between them, it is like the normal, the human relations also. Okay, so okay, let us continue, and then yeah, just if you observe, the dipole moment is the first one is the greater. Okay, so in the first case, the dipole moment will be greater because due to the polarization of CO bond gives aromatic nature to this first compound than the second compound. Okay, yeah, because of that, how to compare? I hope you understood how to compare the dipole moments for the rings compounds. Okay, and then next, how to compare the acidic natures here? Acidic natures को कैसे compare करना है? And then here for this, let me just take, you know, that is, yeah, we have this, and then we have the same compound, that is cyclopentadiene. And now acidic nature का meaning क्या है? The one which loses H plus ion is going to be acid. The one which loses H plus ion very easily is said to be strong acid. And now इधर जो भी हाइड्रोजन्स है बाहर जाना है, ये इधर से ही जाएगा because it is sp3 hybridized. Okay, and then these are sp2 hybridized carbons है, more electronegative है, S character ज़्यादा है. And now simply we can say that is sp2, S character more, electronegativity more, pulling tendency is more, it will not allow the hydrogen to go out easily. But whereas here, this is sp3 hybridized carbon, where the electron density or electronegativity is comparably less. So obviously hydrogen बाहर इधर से जाने का ज़्यादा tendencies है. Similarly here also we have more tendencies of going out hydrogens here. And now because of the losing of the hydrogens, what we are going to get is hydrogen H plus के जैसे बाहर जाएगा, वो बाहर जाएगा ही हमको negative charges आएगा. So we are going to get negative charges. So इधर से हमको जो मिलने वाला ion है, after losing the H plus, we are going to get a negative ion from here, and then here we are also going to get the negative charge from here. And now compare, you know, just compare the acidic strengths. So aromatic जो होगा वो more acidic होगा. Okay, the one which is going to be aromatic is said to be more acidic. These are the ions we get after the remove of the H plus ion. And now once after the removal of H plus ion, they are going to get negative charges on the carbon. And now here, how to identify, how to predict the acidic nature, which is the more acidic one? Yeah, by losing the H plus ion, the one which becomes aromatic, the compound which is going to give us an aromatic compound is said to be more acidic one. And now if you compare, here there is 4 pi electrons, and then this particular system is anti-aromatic. And now if you observe 6 pi electrons, every rules of aromatic rules are being followed. So this is said to be aromatic. So obviously acidic nature किसको ज़्यादा है? Second compound को. So this is more acidic. Hope you understood how to identify. Just you try to remove H plus ion from the sp3 hybridized carbon and then try to take a negative charge. Since hydrogen तो बाहर H plus के जैसे जाएगा तो negative charge आएगा carbon के ऊपर, and then that is going to give us a negative charge. So obviously and now in that product you need to check the nature of the compound. If it is aromatic, then it is more acidic. Clear? Right. Just observe here. Just observe here, and then acidic nature is more for the second compound, because sp3 hybridized bonded directly sp2 hybridized carbon is said to be acidic carbon, okay, and then acidic hydrogens, and if you see, the second compound is more acidic, because the second compound is going to give us an aromatic compound by losing its hydrogen, acidic hydrogen. And now, yeah, this is also similar type of question, yes, where they are asking us to compare. They are asking us to compare the acidic strengths, okay. So let me just give you, the structure either there, okay. And now if you see, yes, we have a double bond here, and then there are two hydrogens. One hydrogen here, there is a methyl group, and then there is a HA, okay, idhar humko HA hai, and then similarly if you see the second one, the same type of compound, there is again CH3, and then we have HB. And now here compare the acidic strengths or acidic natures actually, and now same thing, remove HA, there is actually, this is a labeling, okay, don't get confused, okay, and now this is just a label, and now by losing this H plus, and then we are going to get a negative charge at this particular what do you say that, carbon. So idhar humko negative charge milega, aur ye bhi bahar jaane se हमको इधर नेगेटिव चार्ज मिलेगा. And now obviously because of getting negative charge on this ring, this system is said to be aromatic. This system is going to get aromatic nature, whereas this is non-aromatic, okay. Comparably, which is more stable among aromatic and non-aromatic? Aromatic ring is said to be more stable, and now this is more stable, obviously this is more acidic, so HA is more acidic, okay. HA is more acidic than HB. This is very, very interesting. So I hope you understood. By taking the help of aromatic natures, we can able to solve these all types of questions. This is all about my aromaticity. If you like it, please do share. Don't forget, yes, I have collected all these examples from variety of books, different exams. So I have done all these for you. So please share my channel. Please do share my video. And then yes, I request you, your friends are also might be preparing for IIT, NEET or mains or advanced or any of the state level exams. You please forward this video to them so that they will also get benefit of this. Yes, apart from these examples, अगर ये सब examples तुमको अच्छे से समझ में आया, yes, you can able to do. I'm sure one question we can expect 100% without any doubt. You please check any of your previous JEE papers or previous NEET papers or previous any of your statewide papers. This is the key concept, one of the major concepts in our, what do you say that, for any of the competitive exams. So please I request, I have collected all these examples for you to make you perfect in this aromatic nature. Please, one more point, it's not only aromatic nature we have discussed in this. We have done a variety of problems. Even we have seen the questions related to reactions part. Even we have seen the questions related to dipole moment, acidic nature. All sorts of problems can be easily solved by considering these aromatic natures and all. Thank you so much for watching, and then this is all about this aromaticity. See you soon with a very beautiful video on any of the concepts which are very important for our IIT JEE. Thank you so much.